Now let's now get to the interactive part, testing our export functions once again. Also view the code in chunks. Firstly, let's replace this one. It's a schema like this, and it will be fine. Now let's continue. Let's create a folder here. I will call it test, and inside we'll create a new file called test_api.py. Okay, I will import OS, and also I will import unit test.mock. I will import patch mock open code, okay, and also import pytest, okay, and from API I will import is valid export and write CSV. Of course, here is the two dots. Let's start from import OS and temporary directories, which already saw in chapter 7, files and data persistence, then pytest, and finally valid export write CSV. Before we can write test code, we need to make a few fixtures. Okay, as you will see, a fixture is a function that is decorated with a pytest.fixture decorated. In most cases, we expect fixture to return something so that we can use it in a test. We have some requirement for user dictionary. So let's write a couple of users, one minimal requirement, one with full requirements. Both need to be valid. Here is the code. Okay, let's start with the decorator pytest dot fixture. Def mean user will return email the minimal example.com name. I will say Primus Minimus, age 18. Okay. After that, I will say something very similar, but I will say max user, full user. Okay, I will say email full example.com name Maximus Plenus age 65, and then role emperor. Okay, so let's say in this example the only difference is the presence of the role key, but it's enough to show you the point, I hope. And notice that instead of simply creating dictionaries at a module level, we actually have written two functions that return a dictionary. We have decorated them with a pytest that fixture decorator. It is because when you declare a dictionary at module level, which is supposed to be used in our test, you need to make sure you copied it at the beginning of every test. If you don't, you may have to test that modified it, and this will affect all tests that follow it, compromising their integrity. By using these fixtures, PyTest will give out a new dictionary every test run, so we don't need to go through the paint ourselves. Notice that if a fixture returns another time instead of dict, then that is what you will get in the test. Fixtures will also composable, which means they can be used in another one another, which is a very powerful feature by PyTest. To show you this, let's create a fixture of a list of users in which we put that 2 we already have plus 1 that would be frame validations because it has no age. Let's take a look at the following code. So let's say here PyTest.fixture again, and we see def users, min user, full user, but user equal to email at example.com, name or release, and finally return min user, bad user, and full user. Okay, full user. Nice. So now we have two users that we can use individually, but also we have a list of three users. The first round of tests will be testing how we are validating a user. We will group all the tests for this task within a class. This is not only I have given related tests as namespace, place to be, but as we'll see later on, it allows us to declare class level fixtures, which are defined just for the test belonging to the class. Let's take a look at the following code. Here we say class test is valid page, and I will define some asserts. The test minima equals self, parameter self, min user, assert, assert is valid dot min user, and similarly test full self full user is valid. Okay. We start very simple by making sure our fixtures are actually passing validations, and this is very important. As those fixtures will be used everywhere, we want them to be perfect. Next, we test the age, and two things to be noted here. I will not repeat the class signature, so the code that follows is indented by 4 spaces, and it's because these are all methods within the same class. Okay. And second, we are going to use parameterization quite heavily. Parameterization is a technique that enables us to run the same test multiple times, but feeding different data to it. It's very useful as it allows us to try the test only once with no repetitions, and the result will be very intelligently handled by PyTest, which will run all those tests if they were actually separated. Just provide us with clear error messages when they fail. If you parameterize manually, you lose this feature, and believe me, you won't be happy. Let's see how we test the age. So let's create a new PyTest dot mark dot parameterize age dot range 18 def test invalid age to young self age mean user age equal to age assert not is valid mean user. Here this okay. Here is parameterize okay. Age range okay. There's invalid age to young, invalid age to young, self age mean user age equal to age, assert is not valid. Okay, let's continue. Of course, this is inside. Okay, so we start by writing a test to check the validation phase when the user is too young. According to our rules, a user is too young when they are younger than 18. We check for every age between 0 and 17 by using range. If you take a look at how the parameterization works, you will see we declare the name and an object. We then pass to the signature of the method, and then we specify which values this object will take. For each value, the test will be run once. In the case of this first test, the object's name is age, and the values are all those returned by range 18, which means all integer numbers from 0 to 17 are included. Notice how we fit age to the test method right after self, and then we do something else which is also very interesting. We pass this method a fixture mean underscore user. This has the effect of activating the fixture for the test run, so that we can use it and we can refer to it from within the test. In this case, we simply change the age within the mean user dictionary, and then we verify that the result of is valid mean user is false. We do this last bit by asserting on the fact that not false is true. In PyTest, this is how you check for something. You simply assert that something is true. If that is the case, the test has succeeded. Should it instead be the opposite, the test would fail. Okay, now let's let's proceed and add all the tests needed to make validation fail on the edge. Okay. Add pytest dot mark dot parameterize. I will say age range 66 to 100, depth test invalid parameterize age and that invalid age too old, valid age too old, self, let's pass age and mean user, age will be equal to age, assert not is valid, okay, with a mean user. Similarly, but in this case I will say pytest dot mark parameterize age. I will pass a list of values. I will say none dot 3 dot 14 15 none define a function called test invalid age ground type self dot age dot mean user age equal to age, and finally we'll assert not is valid mean user assert. So another two tests here. One takes care of the other end of the spectrum from 66 years of age to 99. The second one instead makes sure that the age is invalid when it's not an integer number. So we pass some values such as a string, float, and not, just to make sure. Notice how the structure of the test is basically always the same, but thanks to the parameterization we feed very different input arguments to it. Now we won't have to age failing all sorted out. Let's add a test that actually checks that age is within the valid range. So we will define a method very similarly. Parameterize age range. In this case will be range between 18 to 66 and 65. Of course, test valid age self age mean user age will be age, and assert is valid mean user. Okay, it's easy as that. We pass the correct range from 18 to 65 and remove in the not in the assertion. Notice how all tests start with the test prefix have different name. We can consider the age as being taken care of. Let's move on the right test on mandatory fields. Okay, so let's parameterize fields at very similar at by test marked parameterize. In this case will be field and list values, and we say email, name, age. Let's define test mandatory fields self dot field dot mean user dot pop field assert not is valid mean user. Okay, and similarly I will say parameterize mandatory fields empty field mean user is not valid mean user. I will say field my email, name, age. And the last one will be define test name white space only self dot mean user name we will validate these characters /n \n \t assert not is valid mean user there. Okay. The previous three tests still belong to the same class. The first one tests whether a user is invalid when one of the mandatory fields is missing. Notice that every test run the mean user fixture is restored. So we only have one missing field per test run, which is the appropriate way to check for mandatory fields. And we simply pop the key out of the dictionary. This time the parameterization object takes the name field, and by looking at the first test you see all the mandatory fields is the parameterization declarator, email, name and age. In the second one things are a little different. Instead of popping key out, we simply set them, okay, one at a time to the empty string. Finally, in the third one we check for the name to be made of white space only.